Hello, in this video, we will be covering the lifecycle management of Azure VMware solution and pure cloud block store integration. My name is Mazouz, a senior cloud technical evangelist here at Pure Storage. I have been working with Pure for the past 3 years, and since then I have been talking and walking around with my hands in the cloud. So let's get into it. A couple of weeks ago, during VMware Explore, we have announced the latest integration between Azure VMware Solution and Pure Storage offerings in Azure, what we call Pure Cloud Block Store. Pure Cloud Block Store, or short for CPS, is a specification of what we have on our flash array on premises. This offerings of the integration between EVS and CPS is the first fully featured external block that VMware Cloud can offer. What it can do, it can reduce your TCO. How? By independently, you can scale your compute and storage. Also, it can reduce your TCO by leveraging the data reduction ratios that our customers can leverage with the Purity software that lives within the Pure Cloud Block Store or the flash array. And then you can build your cost-effective disaster recoveries across the clouds, across hybrid clouds, or within Azure. And what's really you can do is you can unblock the migration of those heavy lifting workloads, the data sets you could not get into Azure, into a VMware cloud in general. In total here, we are providing a consistent VMware experience. The whole ecosystem of VM building with the flash array, now it's offered in Azure. How we really build it is by leveraging Azure Run Command. Azure Run Command for EVS is a collection of PowerShell commandlets that can enable an EVS user or an EVS admin to run certain vCenter operations that require a root privileges or an enhanced administrative privileges. So Azure or Microsoft, they build those functions in order to maintain the lifecycle management of the offer, and also it will limit the users to run any commands or any operations that will affect the whole lifecycle of the host itself, the ESXi or the vCenter. So we took the same approach, and we've been working with Microsoft for building the EVS management VMFS modules. But we haven't stopped there. What we've done is we've built a wrapper around this modules, what we called using what we're calling the Pure Storage PowerShell SDK, so we can enable our user to do all the initialization, the operations, and also the management of the whole life cycle of EVS hosts, as well as provisioning and managing the storage from CPS VMFS Datastores using the run commands. The wrapper of PowerShell SDKs is available within the Pure Storage plugin OVA, which you can deploy to an EVS VM or within any Azure VM that can authenticate and connect to both CPS and the EVS cluster. So let's go through a couple of those functions. The first one is the build CPS cluster. So this is the first command you need to execute once you deploy the offer. We're going to go through what's the deployments look like, but those are the main functions that you need to do on a daily basis, or just to execute them once that you want to integrate the CPS and EVS. Building the cluster means that we will be executing all the pure CPS or the pure storage best practice with VMware, and also we will be triggering the ESXi to configure the software 𝗦𝗲𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀 within the array itself. But in today's session, I'm going to be trying to focus on the monitor or the life cycle, how we are maintaining the life cycle management of EVS with CPS. More of that in the upcoming slides. Just to give a recap of how a deployment looks like. There's mainly 3 steps here. The first step is you need to deploy your Azure VMware solution, EVS. when you're deploying EVS, you can only choose the region. After it's finished building, you can see the number of hosts you've created within your cluster and also which availability zone you're choosing to deploy. As you can see in this slide here, this private cloud instance has been deployed in availability zone 2. Now, we need to match this availability zone with the 𝗬𝗏𝗀𝗀𝗀 deployment, as 𝗬𝗏𝗀𝗀𝗀 is also a zonal resource. So what we need to do is we need to go to the marketplace, search for pure storage, select the pure 𝗬𝗏𝗀𝗀𝗀 product deployment, and then start filling the requirements. A resource group, a region, the model name, and also the zone. So you need to match those zones. Once you deploy 𝗬𝗏𝗀𝗀𝗀 in the availability zone, what you need to do now, you need to connect them both, the EVS and the CPS, via the express route, a dedicated circuit that comes with EVS. The first thing you need to do here is to go and create a virtual network gateway within the same VNet that CPS resides. Once you do that, then you can just follow the fields here. You just need to make the connection to IPS express route. And the last thing that we need really to emphasize here is you have to make sure you select the fast path for this connectivity to happen. Once this is done, now we can visualize the deployment. As you can see here on the left side, you have the Azure VMware solution environment, the whole stack. On the right side, your subscription, and within the subscription, you have the 𝗬𝗏𝗀𝗀𝗀 with all the backend and the front end components, which will all be wrapped around with the managed application. Those managed application resources will be using the virtual network. And then once you do that, you connect the virtual network gateway with express route circuit, and now you can build a cluster, initialize it, and start creating VMFS volume, attaching them to the SXI hosts. Now we deployed the offers. EVS and CPS are connected. We initialize it, but wait, we still need to make sure that the lifecycle management of EVS is well configured with the CPS configurations. How to do that? First, we need to figure out what are the events that EVS will trigger the lifecycle management, or it might be replacing or adding or removing the SXI hosts. Mainly, there's three things here. EVS host can get replaced automatically if it encounters a hardware failure, or it might undergo a planned SXI version upgrades. This happens more commonly, but the other things that you can do manually is you can add or scale up or remove a host from an existing cluster. Similarly, you can add additional number of nodes by adding additional clusters to an existing EVS private cloud. All of these operations will means that we need to interact from the CPS side to initialize the cluster and also create all of the connections from the SXI host to the CPS in order to have the consistency in terms of the storage data stores each host has. As I mentioned earlier, the function that we've been working on today is deploy BCP as EVS monitor. This function deploys a new Azure resource group that contains a couple of components needed to pull EVS instance lifecycle or the monitoring the host within an EVS, and then automatically go and configure those newer or removing those hosts from the CPS, making sure that the array and the EVS instance are up to date with all the changes. This is a snippet of how I run the deploying the monitor function. We just require you to have your cloud name, EVS cloud name, the EVS resource group, and then the monitoring resource group. If you don't have a monitoring resource group in place, this function will create one, and then you have to choose which region the VNet name where your CPS resides, and then the VNet resource group, the VNet subnet address, so it's going to create you an address, and lastly, the endpoint for CPS. Once the function completes successfully, you will have mainly 5 components. Which components? I'm not going to go into deeply in each one of those. However, the main thing is the application insights will be pulling the status of a cluster or the private cloud instance, checking how many hosts has been replaced, how many hosts has been added or removed, and then once it has that list, it's just using the function app with some PowerShell commandlets to go and execute the build function again. This can happen in intervals, and it will maintain you the life cycle of your deployment. A couple of additional monitoring functions here you need to be aware of. So once the polling infrastructure has been created, there are many other scenarios where you might need to add a CPS array to the cluster. Doing that, you mean to a single EVS instance, I mean here. So those arrays can also be added to the polling infrastructure so that EVS host updates can occur across all the CPS arrays. You can do that by using the new monitor array function. And if you want to have a list of CPS arrays that are registered for the EVS polling or the lifecycle management, you can use the get, and then you can remove those arrays or remove the whole monitoring infrastructure. To visualize this, let me just show you an example of how we can do a host scale-up. So think about you have a cluster, call it cluster 1. This cluster has which is the minimum 3 nodes. Those 3 nodes has already been initialized, and we build the cluster between the array and the EVS. What does it mean? Means that now CBS is mounting 3 volumes. Those volumes are connected to the 3 nodes. Each one of those nodes or hosts has a host object from the array side. All of those host objects are within a host group. It's going to be called cluster 1, similar to what we're calling the EVS cluster. If you will be adding a new node, then the polling mechanism using the monitoring resource group will be getting the new status of the cluster, passing this new list of arrays being added, removed, or replaced to the function. Then the function will be executed against both the CPS and the EVS using the same PowerShell commandlets that we've been using early on this call. Once it has done that, then it's going to create you a new host on the bureau side, do all the configuration, connecting the host, adding the host to the host group, and then initializing the host using the 𝗬𝗲𝗀𝗃𝗃 software, and mounting the same VMFS to the same host. Now you have your cluster 1 with the scaled up nodes, and it can access the same data stores, so you can leverage some clustering environment, or you can share your VMs using vMotion between the nodes. All right, so now we visualized the example, how we want to scale up a host, and then we need to react on that by pulling the infrastructure from the status of EVS and then push that using the function. Now let's go into looking into this with a demo. In my demo here, I've had is my console or the setup I've done on an Azure VM. So I've authenticated to both Azure and CBS. I've already built the cluster, so my cluster is initialized with a couple of hosts within it. It's the minimum 3. And just to show you, those are the commands that I need to I have within my pure storage of CPS EVS. And what I'm going to be using is the deploy command. So I have prepared my commandlet up here. And as I mentioned earlier, you would need to have the EVS cloud name, the EVS resource group, And then the monitoring resource group, you need to select, etc., etc. So now, since my resource group has been created and deployment is in action, I need to move into the Azure console. Once this is finished, I would need to go to my EVS environment. So this is my private cloud. I go to the cluster from the left panel here. And then since I choose cluster 2, I just need to go here, edit. And then I will just need to add one additional node. So click on this, add a host, and I would need to save it. This is going to take a couple of minutes, maybe an hour or so. I will be back, and I'm going to show you how that affected the whole environment or not. All right, I'm back. As you can see, cluster 2 has 4 ESXi hosts. If I will get my VMware credentials and access to the cluster, this is my vSphere client for the EVS. My host has been updated with an additional one, the ESXi09R09. It's connected, and now if I will go and to my Pure Cloud Block Store console, I can see that cluster 2 host group has been added 09. So any VM volume has been attached to this host group should be attached to all the hosts. Back to the vSphere client. If I go to data stores, I have a data store I've created earlier for the cluster. And if I go to hosts, I can see that all the hosts has been updated and attaching to the same VMFS data store. That's it for the demo. Thank you for watching.